Struggling with complex exam concepts? Let us help you build your brain power. Master your studies with ease. Visit examconceptbuilder.com today.
Let's do a super quick rundown of our game plan. We're covering primes, multiples, and factors, then prime factor products, powers and reciprocals, rational versus irrational numbers, and we're capping it all off with a quick fire revision round to test your skills. We are basically lifting weights for your brain today. We're actively building your exam muscle and your confidence. We aren't just passively reading notes here. We're going to actively tackle the most common mistakes students make so that you can avoid them right here, right now, way before you ever step foot into that exam hall. Let's get to work.
All right, kicking things off with Section 1, primes, multiples, and factors.
First up, prime numbers. Look, this is really the only definition you need to memorize. A prime number has exactly two factors, 1 and itself. For example, 2, 3, 5, 7, 11, and so on. Think of them as the indivisible atoms of mathematics. But even though this definition sounds super simple, it actually leads straight into the number one mistake students make on question 1 of the exam. So here is the absolute most crucial thing you need to hear today. 1 is not prime. I repeat, 1 is not a prime number. Why? Well, because to be prime, a number must have exactly two distinct factors. The number 1 only has one factor, which is itself. Write that down, highlight it, put a giant star next to it. Also, keep in mind that 2 is literally the only even prime number. Every other even number can be divided by 2, meaning they instantly have more than two factors.
Okay, let's clear up another common mix-up. Multiples versus factors. We need to compare these directly so you never cross your wires under exam pressure. Multiples are simply your times tables. The multiples of 6 are 6, 12, 18, 24, and they just keep going up forever. Factors, on the other hand, are the exact whole number dividers that fit perfectly into a target number. For the number 12, the factors are 1, 2, 3, 4, 6, and 12. So, multiples multiply and get bigger, factors fit inside and are smaller or equal to the number. And when you're dealing with pairs of numbers, the lowest common multiple, or LCM, is the absolute smallest number found in both times tables, like 15 is for 3 and 5. The highest common factor, or HCF, is the largest divider shared by both, like 6 is for 12 and 18.
Moving right along to Section 2, prime factor products.
So every single whole number out there can be expressed as a product of its prime factors. Think of it like pulling a number apart into its basic Lego bricks. Let's walk through the repeated division method using the number 60. Step 1, we divide 60 by the smallest prime, which is 2. That gives us 2 times 30. Step 2, well, 30 isn't prime, right? So we break it down again into 2 times 15. Now we have 2 times 2 times 15. Step 3, 15 breaks down into 3 times 5. Boom, both are prime. So our final string is 2 times 2 times 3 times 5, which we can neatly write out using indices as 2 squared times 3 times 5.
Now, listen up, because this is where a lot of students accidentally throw away marks. When you're using prime factors to find the highest common factor and lowest common multiple of two really big numbers, you have to compare their index forms. Okay, please burn this golden rule into your memory right now. The HCF uses the lowest power of common factors, while the LCM uses the highest power of all factors. I know, it feels completely backward, doesn't it? The highest common factor uses the lowest power. Getting these powers backward is a huge exam pitfall. Do not fall for it.
All right, Section 3, powers and reciprocals.
A power simply tells you how many times to multiply a base number by itself. Squares, like 4 squared, equals 16, and cubes, like 3 cubed, equals 27. Those are usually pretty straightforward for most students. But let's talk about negative powers. If you have 2 to the power of -1, that equals 1 over 2, or 1/2. I absolutely need to explicitly warn you here. Negative powers create fractions, they do not create negative numbers. A negative index is basically code for division, not a negative value.
And that flows perfectly into our next definition, the reciprocal. The reciprocal of a number is simply 1 divided by that number. Honestly, the absolute easiest way to think about it is just flip the fraction. The reciprocal of 7 is 1 over 7. But here is the classic trap. Take -4, for instance. The reciprocal of -4 is -1 over 4. Notice something? When you flip the fraction, the negative sign stays exactly where it is. Please do not lose your negative signs when you're rushing under pressure.
Almost at the finish line. Section 4,
Rational versus irrational numbers. Here's the easiest way to tell these two apart. A rational number is any number that can be penned down exactly as a simple fraction of two integers. 3/7 is rational. So is 0.6, because that's just 6/10 or 3/5. Even repeating decimals like 0.333 are rational, because they equal exactly 1/3. On the flip side, irrational numbers are the wild ones. They literally cannot be written as a neat fraction. Their decimals go on forever and ever without ever repeating a pattern. The most famous example is obviously pi, but square roots of non-square numbers, like the square root of 2, are also irrational.
Which brings us to a massive key rule. The square root of n is irrational unless n is a perfect square. I'm stressing this exact rule so you don't get tricked on the test. If an exam asks you to categorize the square root of 9, don't just blindly write irrational just because you see a root sign. The square root of 9 is exactly 3, which is totally rational. But the square root of 5? That's irrational, because 5 is not a perfect square like 1, 4, 9, or 16.
All right, Section 5. It is time for a quick-fire revision round.
Let's put that active recall to the test. I'm going to ask a question, and I want you to try and lock in the answer in your head before I reveal it. First question, is 263 a prime number? Think back to the root testing method we discussed. How high do you actually need to check to know for sure?
The answer is yes. But hey, how do we actually know that without sitting there and testing every single number all the way up to 263? Well, you only need to test prime numbers up to the square root of your target number. The square root of 263 is about 16.2. So if we divide 263 by 2, 3, 5, 7, 11, and 13, and literally none of them divide perfectly, which, spoiler alert, they don't, then we can confidently declare it certainly is prime. You don't even need to bother checking 17 or anything higher. Okay, let's see how this builds your speed. Next rapid-fire question. What is the lowest common multiple, or LCM, of 3 and 5? Don't overthink this one, just use your times tables.
And the answer is 15. We are just looking for the absolute smallest number that shows up in both the 3 times table and the 5 times table. 3 times 5 is 15, and since they share no other smaller common multiples, 15 is the winner.
Let's test your grasp on large powers. If 100 million equals 10 to the power of x, what exactly is the value of x? Try to just visualize the number 100 million in your head for a second.
It's 8. If you literally just write out 100 million as a 1 followed by zeros, you get 100, 000, 000. Count them up, and you'll see exactly 8 zeros. Since every single zero represents multiplying by 10, x equals 8. It's simple, it's visual, and it is a highly effective trick for the exam.
All right, let's hit you with one final question. From our reciprocal section, what is the reciprocal of the fraction 3/5? Remember that super simple rule we talked about for fractions.
5/3. You literally just flip the fraction. And with that, you have successfully powered through this explainer on number facts. By reviewing these concepts, hyper-focusing on those common mistake alerts, like 1 is not prime, and understanding how to practically apply rules like finding the LCM using prime factor products, you are setting yourself up for serious success on your IGCSE exam. Now, I'm going to leave you with one final thought to mull over before your next study session. Out of everything we covered today, which number fact rule still trips you up the most? Identify it, practice it, and completely master it. Thanks for learning with me today, and I'll see you in the next explainer.